Let's look at this mixture problem. A chemist mixes 20 liters of 40% acid solution with 70% acid solution to obtain a mixture that is 50% acid. We are looking for how many liters of the 70% acid solution should be used. So the mixture problem involves like 3 solutions. Let's say in this blue container, we have 20 liters, 40% acid solution. That is given. The problem tells us in the blue container, we have 20 liters, 40% acid solution. In the black container, we have 70% acid solution. We are looking for how many liters we need to make the mixture in the red container. So here we let X be the liters of 70% solution in the black container. So we put the content in these 2 containers in this red container. We want the acid solution in this container is 50%. So half acid, half water. Since we pour 20 liters here, 20 liters, 40% here, X liters, 70% here, we should have 20 plus X liters solutions in the bigger container, in the red container, right? Yeah. So X is the value we are looking for. In order to find a value for X, we need to create an equation. In order to create an equation, we consider the amount of acid in each container. In the blue container, we have 40% times 20 liters acid. Did we talk about this? OF here means multiply. Yeah, in the blue container, we have 40% of 20 liters solution. So 40% times 20, that's how many liters acid in the blue container. So we agree on this on Friday, right? In the black container, the amount of acid is 70% times X. In the red container, the amount of acid is 50% times, inside the parentheses, we have 20 plus X. Half of the 20 plus X liters, that's the acid. The acid in the red container comes from the acid in the blue and the acid in the black, right? So we have this equation. The acid in the blue plus the acid in the black equals the acid in the red container. So that's the equation we set up on Friday. Let's see how do we solve this equation. One method is we can remove all the percentage symbol in the equation. We have 3 parts in the equation. All the parts have a percentage symbol. We can remove them all. And the equation becomes 40 times 20 plus 70 times X. On the right hand side, we have 50 times parentheses, in which we have 20 plus X. Let's apply the distributive property to simplify the right hand side. Can you help me with the distributive property? 50 times parentheses. How do we distribute? We learned distributive property in chapter 1, right? What's the coefficient of the parentheses? What's the number in front of the parentheses? The number associated with the parentheses. 50, yeah. So we're going to use 50 to multiply each single term in the parentheses. 50 times 20, what is 50 times 20? 1,000? Am I right? Okay. And what is 50 times X? Plus 50 times X, right? Yeah, pretty straightforward. On the left, what is 40 times 20? 800, very good. And plus 70 times X. At this point, the equation contains how many terms? 4 terms. Yeah, 2 terms on the left, 2 terms on the right, right? Yeah, 4 terms in total. So I'm going to color them. This term, orange and purple. Among the 4 terms, which of them are variable terms? Yeah, which terms contain x? Tell me the color. Green and purple, yeah. So when we solve the equation, we try to isolate the x on the left, right? So in order to isolate the x on the left, we need to collect the variable terms on the left first. So we want a green and a purple on the left. I'm going to apply my transposition of terms. The green term, I don't change it. Yeah, 70 times x is gonna remain on the left, so nothing has changed. The purple term, 50 times x, I'm going to move it to the left. I move it and I change the sign. You see that? Yeah, so green doesn't change nothing. The purple, I move it and I change the sign. On the right hand side, the green, orange term, 1,000, it doesn't change anything, so I just copy it. The 800 on the left, do we want 800 on the right hand side? Because it's a constant, right? Yeah. So transposition of terms, we move it and we change the sign. Very important. Move it and change the sign. Yeah, I hope you practice this technique. It's very useful and convenient. Once we collect like terms, we have the green and the purple on the left. We have the orange and the blue on the right. Yeah, we can combine the like terms. What is 70x times 50x? 70x times 50x. 20x, yeah. Combine like terms is to combine their coefficients, right? 70 apples, and I take away 50, and you have 20 left. On the right hand side, what is 1,000 minus 800? 200, yeah. How do we continue here? Almost there. Divide, right? Because the coefficient of x is 20 now. We're going to divide both sides by the coefficient 20. What is x? 10 liters, yeah. So we should put 10 liters in the 10 liters. So 7, 8, yeah, that's correct. So 10 liters here in the black container. So we should have 10 liters, 70% acid solution. Yeah, we should use that amount of 70% acid solution to make the mixture. About the solution, about solving this equation, I want to start from here. So we are here, right? That's the equation. I'm going to use another different method to solve it. So let's move this equation. Let me copy it here. 40% times 20 plus 70% times x equals, on the right hand side, 50% times parentheses 20 plus x. Yeah. So now we are going to deal with the percentage symbol in a different way. This time, we are going to convert percentage to its equivalent decimal. This is a good chance to show you how do we convert. How do we convert decimals? Convert a percentage. Convert a percentage to its equivalent decimal. Okay, yeah, let's take time to look at that. Let's look at the first percentage. The first percentage is 40%. Let's think about what is a percent. Per means every. Cent, let's think about a century. Century is 100 years, right? So cent means 100 years. 100, not 100 years, I'm sorry. Cent means 100. So percent means every 100. 40% means 40 every 100. Yeah, every 100 we have 40. So that actually means 40 out of 100. All right? Yeah. Every 100 we have 40. Yeah. Amount of 40 we have 40. Amount of 100 we have 40. So 40%. Every 100 we have 40. So 40% is 40 over 100. So whatever the percentage point here, this number, you just put a number in the numerator and put 100 in the denominator. Okay, you have a calculator. Tell me, what is 40 divided by 100 as decimal? 40% is 40 divided by 100. Tell me the decimal, yeah? 0.4 exactly, yeah. So that is how do you convert a percentage to decimal. So let's write 0.4 here to replace 40%, and then multiply by 20 plus, how do you convert a 70% to decimal? 70%, 70 every 100, 70 over 100. What is it? 0.7, yeah, 0.7 times x. On the right hand side, 50%, 50 out of 100. 50 in the numerator, 100 in the denominator. What's its equivalent decimal? 0.5, exactly. Okay, yeah. So I would say it's safer if you convert all the percentages to its equivalent decimal and then you process. The first method, remove the percentage, is kind of tricky. You have to really see the percentage symbol is on every term. Then you can remove it. Let's continue here. Calculator, what is 0.4 times 20? 8, yeah. And then we copy 0.7 times x on the left. Let's distribute. 0.5 times 20, 10, right? Plus 0.5 times x. And we have 4 terms again in the equation. We want a 0.7x on the left. It is already on the left. We want a 0.5x on the left, so we move it. Do we change the sign or not? Yeah. So we have a negative 0.5x on the left. On the right hand side, we bring down 10. So nothing has changed for 10. And then we want this 8 to the right hand side. So we move it and change the sign, right? Yeah. 0.7x times 0.5x, 0.2x. 10 minus 8, 2. And you divide both sides by 0.2. You will have x equals 10. Would it be the same? The answer, of course, will be the same. Depends on your preference. If you are able to handle decimal, this way is safer. Yeah. So we use this example to explain how do we convert a percentage to its equivalent decimal. All right? Any question about this mixture problem? It's pretty important because the coming test 2 will have a problem like that, a mixture problem. So that is section 2.5. Let's look at some problem in 2.6. We plan to have test 2 the coming Monday, okay? Yeah. Oh, no, I'm sorry, my bad. This is an everyday class. So we plan to have a test, we probably will have on Wednesday. Yeah. Oh, no, maybe Thursday. We'll see that. We'll see that. Oh, you need to get ready for test 2 this week, though. You need to get ready for test 2 this week. Okay? All right. Let's see, 2.6, formula and additional application. So 2.6 is the application of linear equation in 2 variables in geometry. Geometry, yeah. We're going to see some formulas in geometry and maybe in business. Most of the formulas are in geometry, though. Okay, so what is a formula? A formula is an equation in which variables are used to describe a relationship. For example, formulas exist for finding parameters and areas of geometrical figures, calculating money earned on bank savings, and converting among measurements. So what is a formula? My definition for formula is a formula is an equation in which there are more than one variables. So the equation shows you the relationship between those variables. Yeah, that's my understanding about formula. Let me repeat it. What is a formula? Formula is an equation. So you will see equal sign in a formula. Yeah. But in the formula, in the equation, you have more than one variables, sometimes 2 or 3 or even more. Yeah. So the equation tells you the relationship between those variables. So that is a formula. Okay. Yeah. For example, are you familiar with this formula, this equation? F equals 9/5 times C plus 32. Are you familiar with that? If you travel? No? Okay. C here is Celsius. Degree in Celsius, temperature. Yes, Celsius. Celsius? Celsius? Here. C degree, yeah, temperature. Temperature degree in Celsius. Yeah, I think my pronunciation is correct, right? Celsius. Okay. Yeah. F here is the temperature degree in Fahrenheit. Yeah, you know that, right? Fahrenheit. Yeah. We use Fahrenheit in this country, but actually, many other countries they use Celsius. Yeah. So how do you know? For example, how do you convert the temperature in Fahrenheit to its equivalent temperature in Celsius, right? And vice versa. How do you convert the temperature in Celsius to its equivalent temperature in Fahrenheit? So if you look at some baking recipe, right? Like you put the recipe in the oven for how many Fahrenheit degree? So what if you use Celsius? How do you convert it between? How do you convert it to its equivalent degree in Celsius? So this formula tells us how do you convert from Celsius to Fahrenheit? Okay, from Celsius to Fahrenheit. For example, in Celsius, the best temperature for me is 24 degree. 24 degree in Celsius. Room temperature, 24 degree in Celsius. Okay. So if you plug in C equals 24, I want you to do this right now. Yeah. Can you plug in C equals 24 right here and then tell me what's the room temperature in Fahrenheit? Yeah, let's see how do we do that. Am I clear about the thing we are going to do? Let me copy the formula right here. F equals 9/5 times C plus 32. Yeah. 24 Celsius. That's the room temperature. Room temperature. Yeah, that's the room temperature. Let's see. The room temperature is how many degrees in Fahrenheit? So we are going to plug in C equals 24, right? You see that? Plus 32. Yeah, I gave you a little time and you tell me what is it. You can convert 9/5 as decimal if that's easier for you, right? 9 divided by 5 as decimal is 1.8. 1.8 times 24. And then plus 32. Yeah, what's the answer you got? What is it? Anyone has an answer? What is it? So how you see the structure? This is a number, right? The number times 24 and then plus 32, right? Remember the correct order of operations. Multiplication before addition. Multiplication before addition. Get your calculator, please. Tell me what is 9/5 in decimal. 9 divided by 5 in decimal. Yeah, 1.8. Multiply 1.8 by 24, what do you have? Yeah. 0.2. And then plus 32. Yeah, plus 32. 75.2. Yeah, so the temperature, room temperature was 24 degrees in Celsius is 75.2 degrees in Fahrenheit. Yeah, this is a pretty comfortable temperature, right? Yeah, maybe in the early morning, in the summer here. So we just use the formula. See that? That's the purpose of formula. That's the purpose of formula. Formulas are equations. Display the relationship between variables in the formula. Okay, let's see other formulas right here in the example. P equals 4s. Yeah. P equals 4s. What kind of formula that is? This is a square. Square has 4 sides, 4 angles, right? The 4 sides are equal. 1, 2, 3, 4. The 4 sides are equal. And the angle between the sides are 90 degrees. So that is a square. We're familiar with the square, right? And P equals 4s. P here is a parameter. P here is the parameter of a square. What is a parameter? Parameter is the distance around a figure. Yeah, the distance around the figure. So this is square. Parameter means, for example, we start from here, the distance around the figure. So we have a 1s, another s, another s, and another s, right? So there's a 4s. So that's a parameter. Parameter of a square equals 4 times the side, the length of the side. S here means the side, initial side. So once again, so we get familiar with what is the formula, how do we use them? Let's look at this formula. A star, the fancy A, could be just a regular capital A. A equals pi r squared. Anyone remember what kind of formula that is? A equals pi r squared. Circle, remember that? Pi r squared. This formula is the area of a circle. A here is the area of the circle. Pi here is a constant. It's the irrational number, the crazy decimal. It is around equal to 3.14 and so on and so on, right? It's a constant. R here is the radius of a circle. We know what is the radius doing? Radius? Yeah, we know what is the radius, right? Radius is the distance between the center of the circle and any point on the circle. So let's say this is circle, right? This is center, right? You randomly pick any point on the circle and you connect the point and the center, and that distance is the radius. Yeah, radius. Do we know what is diameter? Twice of radius. Do you see diameter is twice of radius, right? Yeah, okay, very good. So area of a circle is a pi r squared. Square of the radius, pi, that's the area of the circle. Yeah, those formulas are pretty straightforward, pretty common. We should know that. Let's see this formula. I equals PRT. This formula is in business. P here is the principal. R here is the annual interest rate. T here is the time in year. I here is the simple interest. Yeah, so this formula is to compute or calculate simple interest. Yeah, how do we understand this formula? I here is the initial of interest, right? Interest, yeah. I equals PRT. P here is the principal. What is the principal? For example, you have $100, right? You don't use the $100 for a year, so you put the $100 in the bank. You deposit it in the bank because you do not use the money for a year, and the bank can use it for investment or other things, right? So the bank will pay you interest. Okay? Yeah. In return, the bank, because the bank could use your money for a year, the bank will pay you interest. Suppose the interest is simple interest. Then how much interest you will have depends on this formula. Yeah, it equals the principal times the interest rate. Let's say it's 5%. The simple interest rate, the annual interest rate is 5%. So it means that by the end of the year, you will have $5 as you have 5%. You will have 5% of the $100 as interest. 5% of $100 happen to be $5, right? Yeah. T here is the time in year. You put your money in the bank for a year, so t equals 1. So we need to understand this formula. I here is simple interest. T here is principal. R here is annual interest rate. T here is time in year. Simple interest. If you go to college algebra, you will learn compound interest. Yeah, those two types of interest are different because the formula is different. Yeah, they are calculated as different way. This is for simple interest. Let's do some practice. Number 13. So we try to do the 4 problems here. 5 problems. 13, 14, 15, 8, 16, 7. 5 problems here. See. Number 13. It's kind of like a brick, right? Or box. It's called a prism. Prism. The formula which given here, V equals L times W times H. That formula is the volume of the prism. V here represents the volume. V here represents the volume. Yeah. Volume of that box, let's say the prism is a box, is L times W times H. What is L? L is the length of the bottom, the base, length of the base. Width is the shorter side of the base. Height, we know what is height, right? Or thickness of the box. Yeah. So this is a 3-dimensional thing. The volume equals the length times the width times the height. We are given length is 10, width is 3, height is 1. What's the volume? Can you calculate what is the volume? 30? Exactly. This is easy, right? All you need to do is to multiply them all together. And that's an easy one. Let's see number 14. This is a sphere, not a circle. Not a circle in 2-dimensional space. This is a sphere like a ball. Basketball, soccer ball. Yeah. It's a ball in 3-dimensional space. Then this formula is the volume of a sphere. Volume of a sphere. Yeah. V equals 4/3 times pi times r cubed. Anyone can guess what's r here represent? Radius, yeah. Radius of a sphere. Yeah, how do we understand radius of a sphere? Yeah, imagine the ball that you play, yeah, the basketball or soccer ball. It has a center, right? Yeah. So any point on the ball, on the surface of the ball, the distance between the center and then the point, that's the radius. Similar with the 2-dimensional circle, but this is 3-dimensional. This is the center. This is any point on the sphere. The distance between the center and any point on the sphere is the radius. Yeah. This is the volume of a sphere, 4/3 times pi times r cubed. We know r is 2 inches. We're going to use 3.14 as the approximation of pi. And then can you find the volume for the sphere? Can you do that? Suppose we know the radius is 2 inches. For pi, we can use 3.14. Yeah, what's the volume? It's pretty straightforward. It's a problem from my lab math. see v equals 4/3 times pi. Pi, the problem asks us to use 3.14, right? Yeah, times 3.14 times r cube. R is 2. R is 2. So we have a 2 cube here. Yeah, you want to follow the correct order of operations. What is a 2 cube? Let's see. Yeah, 2 cube is 8. Yeah. We have 8 times 3.14 times 4. What do you have? Round the answer to the nearest hundredth as needed. You will have an irrational number, but you have to round the decimal. What do you have? Is around equal to 33.493333, and so on. Okay, it's a rational number because we already rounded the pi as 3.14. Yeah, how do you round the nearest hundredths as needed? We learned decimal. We're gonna use this problem to see how do we round a decimal. What is the round decimal to the nearest hundredth? Do you see the decimal separator here? You see the decimal separator? Yeah. So this is a kind of ones. This is 100, right? And this is a tenth, TNTHS. This is 100th. Yeah, this is 100th. Yeah. So we need a round to the nearest hundredth. So we're gonna look at the digit right after it. If the number is bigger than 5, bigger than or equal to 5, then we're gonna round it up. If this number is smaller than 5, we're gonna round it down. Since this number is 3 is less than 5, we're gonna round the number down. So the nearest hundredth would be 33.49. Okay, yeah, round a decimal. That's how do we round a decimal. Any questions? Any questions? So far so good? Number 15. Simple interest. Are you able to see the words? Big enough for you to see. Simple interest I in dollars is calculated using the formula I equals PRT. We had this formula explained earlier, right? I is the simple interest, P principal, R annual interest rate, T timing in years. How about let me copy and paste and make it bigger? Let's see. Would this be better? Too wide, the thing is. P here represents the principal or amount in dollars that is invested or borrowed. R here represents the annual interest rate expressed as a percent. T here represents time in years. Find the value of the remaining variable in the simple interest formula. Write percents as decimals. So, okay, let's see. The formula is I equals P times R times T. We know I equals 600. R is given 5%. T is given 3. Yeah, which value is unknown here? Which variable is unknown here? P is unknown. Yeah, P principal is unknown. Okay, Let me show you how do we solve for P in this problem. How many variables in the equation or in the formula? How many variables in the formula? 4, yeah. 3 of them, the values are given, right? The values for 3 of the variables are given. How about let's plug in the values. I is 600. P is unknown, so let's copy P here. R is 5%. Anyone can help me to convert 5% to its equivalent decimal? To its equivalent decimal, 5%. Percent per 100, every 100. 5 every 100, what is it? Try your calculator. Try your calculator. Try your calculator to convert 5% to its equivalent decimal. 0.05, right? Yeah, exactly. 0.05, exactly. Very good. Times t, what is t? T is 3 years, so we copy it here. Yeah. On the right hand side, how do we understand this part? That part actually is the coefficient of p. Yeah, variable p times the number, right? Yeah, so this part actually, you can see that as the coefficient of p. Tell me what is 0.05 times 3? Triple of 0.05. Triple of 0.05. What is it? 15, yeah. Could I write the number 0.15 in front of p? Yeah, it was p times 0.15, right? The green part, 0.05 times 3 is 0.15. Could I interchange the order of the two quantities? Write a number in front of the variable. Commutative property for multiplication of real numbers. We can do that. We could do that positively. So we have 0.15 times p equals 600. Yeah, if you still don't see it, let's interchange the two sides of the equation. 0.15 times p equals 600. Remember, equation is like a scale, right? All we need to do is to keep the balance of scale. If we interchange the size of the scale, does that matter for keeping the balance of the scale? It won't change the balance, right? Yeah, you just switch the size. So it's the same. What's the coefficient of p again here? 0.15, yeah. How do we isolate the p here? P is the variable. We divide both sides by 0.15. Yeah, let me know what is the value. 600 divided by 0.15. 4,000, yeah. 4,000, so let me write it here. $4,000. And let's interpret the result. Simple interest. When the simple interest rate, when the annual interest rate is 5%, well, it's pretty high, to be honest. Right now, interest rate is super low, but like a half century ago, the interest rate is pretty high. That's possible, but now it's not possible for that high interest rate. Anyway, so if you wanna have $600, if you wanna have $600 profit by sacrificing your money for 3 years, yeah, how much money you sacrifice, like deposit it in a bank, and you don't have to spend it for 3 years, 4,000. You deposit $4,000 in the bank for 3 years. And after 3 years, you will have $4,600. Yeah. Let's flip this thing. What if you borrow? What if you borrow $4,000 from the bank, and the bank charges you simple interest for 5% annual interest rate for 3 years? Then during the 3 years, you have to pay the bank $600. See what I'm talking about? Yeah. It depends on the 3 quantities: principal, interest rate and time in years. Any question about this problem? Yeah, from test 2, you could use a calculator. Let's see problem number 16. Again, about the simple interest. I here in dollars is the simple interest, P is the principal, R is the annual interest rate, T is the time in year. This time we know I is $660, principal is $4,800, R is 5.5%. This time we are looking for T. Yeah, T. The formula is I equals P times R times T. For variables, and we are given the value of I, 660. We also know the principal for the 800. We also know the interest rate, annual interest rate is 5.5%. Yeah, T is the only unknown variable. Let's see how do we solve that. This part again, the whole thing can be seen as the coefficient of T. Firstly, can you convert 5.5% as equivalent decimal? 5.5% as its equivalent decimal. 5.5%. 5.5 every 100. So that is 5.5 over 100, right? Use your calculator. What do you have? Exactly, 0.055. Exactly. Multiply the decimal by 4,800. Tell me what you have. 0.055 times 4,800. 264, right? Yeah. 264 times T. How do we find the value for T? How do we find the value for T? Divide both sides by what? Yeah, divide both sides by the coefficient of T. The coefficient of T is not 660, it is 264. So this way, T can be isolated on the right-hand side. Let's see what is 660 divided by 264. What do you have? I got a 2.5. Do you have the same thing? Yes or no? Yeah, let's interpret the result. If you have $4,800 extra money you want to invest, you know the bank will pay simple interest. The annual interest rate is 5.5%. Like every year for $100, you get $5.50 interest. Yeah. So how long you're gonna leave your money in the bank in order to receive $660 interest? How long? 2.5 years. 2 years and a half. If you leave your money in the bank for 2 years and a half, after that you will have $660 interest profit. And we're gonna stop here and continue tomorrow. Yeah, we probably will have a test on either Thursday or Friday. Maybe Thursday. Maybe Thursday. Because today we done the application. Tomorrow we will do the last section of the chapter. And on Wednesday we can do the review. So yeah, probably on Thursday we'll have test 2. Thank you guys for coming. I'll see you tomorrow.